All right, we're going to be working on lesson 2 of module 5. In class, the first thing that they did was played a game at the carnival. The students were spinning a large spinner. It has 4 equal sections, 1 through 4. And what they did was they spun it twice. Results of the first spin, results of the second spin. Then they added the 2 numbers to get the sum. They were trying to find out if the sum was greater than 5, and if it was, they would win a prize. So that was an activity that was done in class. If you'd like to spin on the spinner and come up with some results, you would be able to answer the next page. Now, this page all turns out to be questions answered based on the experiment of spinning the spinner. So unless you do that spinner activity, you won't be able to do this page. But if you want to try it, then you can answer these questions on page 11. Now, page 12 talks about finding the probability based on the experiment of spinning the spinner. So you can use those results to estimate the probability of an event. So you were spinning it 15 times and you were counting to see how many times it was greater than or equal to 5. So the way we write this in math is we write capital P for the probability. Whatever you're finding the probability of goes inside parentheses. So in this case, we're finding the sum greater than or equal to 5. And then you would say, well, how many times did we get 5 or greater over the total number that we did? Once again, 7 and 8 is based off of the previous page. So once you have completed that, you can answer page number 7 and 8. And since everybody in the class did their experiment on their own, they all had different responses. So there's not one correct answer because it's based off of your experiment. All right, example 2. A student brought a very large jar of animal crackers to share with students in class, and rather than count and sort all of the different types of crackers, the students randomly chose 20 crackers and found the following counts for the different types of animal crackers. Let's estimate the probability of selecting a zebra. So just like the example previously, we're going to write capital P for probability, and we're trying to find the probability of a zebra. So in parentheses, I'm going to write zebra. So if you look at the chart, zebras occurred 3 times out of the total 20 animal crackers. So our probability is 3 out of 20. That doesn't reduce. Now that's a fraction. Sometimes you'll see probability written as a decimal, not likely, but sometimes. Most of the time it's going to be written as a percent. So let's remember how to do that. We're going to take 3 divided by 20. That will give you a decimal. And to find the percent, you're just going to move it over twice, which would be 15%. So you have 3 different answers there, all the same thing. All right, so the next example, 9 through 15, is still based on the crackers, that chart that we just looked at. So what is the probability of selecting a lion? So you're going to do probability of a lion. If you look at the chart before, on the previous page, there were 2 lions out of 20. Now let's reduce the fraction. So that would be a 1 out of 10 chance. As a decimal, that's 0.1 or 0.10, which is a 10% chance of selecting a lion. Number 10, what is the probability of selecting a monkey? So capital P, monkey. So on the page before, there were 4 monkeys out of 20, which reduces to 1/5. 1/5 is the same thing as 0.2 or 20%. Now, number 11, what is the probability of selecting a penguin or a camel? So penguin or camel. So it doesn't matter which one. So how many penguins and camels are there? Well, if you add them up, it's 1 camel, 3 penguins. So that's a total of 4 chances to get either one of those. Out of 20, that reduces to 1/5 or 0.2 or 20%. Number 12, what is the probability of selecting a rabbit? So probability of rabbit Now, if you look at the chart, there's 0 rabbits out of 20, which is a 0 or 0%. So you are never going to get a rabbit because there is no rabbits. It is impossible. Number 13 is there the same number of each kind of animal cracker in the jar? So is there the same number? From our chart, we can say no. There's different amounts of each animal. So if a student randomly selected another 20 animal crackers, do you think the results would be the same? Well, if you're randomly selecting it, do you think you would get the same every single time you selected? And the answer to that would be no. And you could say because it is a chance experiment. Results will not be the same. So if there's 500 animal crackers in a jar, how many elephants? Well, let's think about this. What's the probability of getting an elephant? Well, if you look at the chart, there's 5 out of 20 elephants, which is 1/4. 1/4 is 0.25 or 25%. Now, we just finished with the percents unit, and we know that if elephants are 25% of the jar and 500 is the total in the jar, we can use part equals percent times whole to figure out how many elephants there would be. So the part would be the number of elephants. It's 25% of the whole jar. The whole jar is 500. So 0.25 times 500 gives us 125 elephants. This question is often asked on New York State tests. They like to say how many total, but you have to find the percentage before you actually use part equals percent times whole. And that is the entire lesson. Your problem set is on the very next page. That is your homework for tonight.